Hey, Honors Chemistry. I wanted to post some review problems that I kind of took from the review and from past worksheets to make sure that you could better prepare for our unit test this week. So one of the first questions on your review sheet says, explain why the level in an alcohol thermometer rises when it is placed in warmer fluid. Now, I believe it said that there's a three-step process, and we're going to go through that. So let's say I'm going to draw my thermometer. I'm just going to draw it as a tube. And I have my markings on here. And I'll draw my particles in here. If I zoom in, my particles are moving at, let's say I have this just at air. They're moving at whatever temperature is in the air. Let's just call it room temperature. So they're moving at room temperature speed. Then, if I place that thermometer into a thing of warm fluid, so let's say it was in I'll put it in like a bowl of warm fluid. What's going to happen to those particles when I have them in fluid that's moving a lot faster? And how do I know they're moving a lot faster? Because I told you it's warmer. And we know with an increase in temperature, particles move faster. So remember that. So what's going to happen to these particles with the particles that were inside my thermometer? Well, there is going to be heat transfer or energy transfer. So heat transfers from hot to cold or hot to less hot, because we've talked about cold not existing. And so instead of my thermometer being down here where it was, should it go up or down? Well, we should know with an increase in temperature, with particles moving faster, there's going to be an expansion, which is the word that you need to use. So my particles are going to go from being down here to being up here a little bit more. They expand more. And so if I were to zoom in on those particles, they are now moving a little bit faster. And they're moving as fast as whatever was touching it. And I show moving faster with double arrows. So notice I only have one arrow here, and then I have a double arrow for moving faster. So if I were to do this in 3 steps, I would say heat is transferred, particles move faster, and then because particles are moving faster, particles are able to expand. Particles expand or spread out. Because that is the basic property that happens in a thermometer. It's expansion and contraction. The other question says, what happens if you put the particles in contact with something that's colder or less warmer? Well, the particles will move slower and they'll contract or get closer together. Okay, so if you have a question or if you see a question about what happens inside a thermometer, make sure you're able to explain it using images and diagrams like this. Another question that I want us to consider is how a barometer works. Now, if you remember, a barometer is an instrument that reads pressure. Typically atmospheric pressure, yes. Okay, so I kind of quickly drew a sketch, it's an amazing sketch, I know, of mercury in a barometer. These are our mercury particles, and I zoomed in and I drew in our mercury particles. And it's open to the air, and I have mercury in a tube. So the mercury in a tube stops here. And do you remember what atmospheric pressure is approximately? What our scientists discovered when I watched that first video, or when we watched that first video? This height should be about 0.76 meters or 760 millimeters of mercury. That's typical atmospheric pressure. And that's because air particles, so I'll just draw a quick sketch of air particles. Air particles are pushing down on this mercury and making it go up the tube. So they are colliding. The air particles collide or push the mercury particles to move up the tube. Now, if it was pushing less, and this is a question that you may have to encounter, if it pushes less, meaning lower pressure, would this be higher up? Would the mercury be higher in the barometer, or would it be lower if it was pushing less? Well, if it pushes less and it's a lower pressure, then I should have a lower level in the barometer. So the height of mercury is lower. If somehow atmospheric pressure was pushing more, would the height increase or decrease? Well, if somehow the atmospheric pressure was pushing more, the height should increase. So make sure you remember, and there's a video posted in the Google Classroom, and it's a video we watched in class on where the barometer came about and what we could do with it. But just recall how we read barometers and how mercury moves because air is pushing it to move. All right, there's that collision, and we know that pressure, remember that pressure has to do with collisions of particles with each other and the wall of the container. So pressure has to do with collisions of particles with each other and the walls of the container. And then the last review question that I want to go over is how we read a manometer. Now I'm taking this from worksheet number 2, but I want to review. I have both these manometers open to the air. So the way a manometer works, and I'm just going to start with this first one, is you have atmospheric pressure or pressure in the room pushing into here, and then you have a gas in a tube that's also pushing against it. Okay? So I'm going to draw a pushing arrow, right? So we have a push this way, and we have a push this way, kind of like the barometer, except it's in an open end and a closed end here. So if this is pushing more or less, I could figure out whether or not my gas pressure is higher or lower. Well, since I see that my gas pressure is pushing more, all right, and how do I know that? It's because this level is lower than this level. So if this is pushing more, this is going to push this up this way, as opposed to, and I purposely drew this here, look at this difference. If this was this is pushing, the air is pushing more this way. Otherwise, if this was pushing more, this would move this to go up the tube that way. So look at the difference in these two and how, and I'm going to go back to this problem after. This gas is pushing more against the atmospheric pressure, whereas this gas, the atmospheric pressure is pushing more against it. So in the event where the gas is pushing more against the atmospheric pressure, P of the gas is going to be greater than P of the atmospheric pressure. Or we call that, if it's been given to you, as P of the room. So now if I know in this instance that my pressure of my gas must be greater than my atmosphere, I know I have to add something to atmospheric pressure. So we look at these height differences. This height difference tells us how much the mercury has been pushed or pulled in both directions. We need to do the height difference of the mercury in here, because this is mercury. That height difference is what we use to figure out the pressure of the gas. So I'll do 127 millimeters minus 84 millimeters, and that's equal to 43 millimeters of mercury. And now the way that you do this is I figure out whether I add this difference or I subtract this difference to atmospheric pressure. Well, if I know that the pressure of my gas is pushing more against it, that means it's pushing against the atmosphere a little bit more than atmospheric pressure. So in this instance, I have to add the height difference. So if I do this math, I should do P of the room plus the difference equals P of the gas. Okay, and I only do this if it looks like my gas is pushing down against the atmosphere. I have to add to it. So I'll do, P of the room was given to me before as 730. So I'll do 730 millimeters of mercury plus 43 was my difference, millimeters of mercury. And that equals 773 millimeters of mercury. So this is larger than atmospheric pressure, and it's okay because the pressure of this gas in this tube is larger than atmospheric pressure. On the other hand, and I'll do this problem quickly, I see that it looks like my atmosphere is pushing more against my gas. Atmosphere pushes against gas. All right, so I can see that because the liquid in this level is tilted more towards the gas, which means it's been pushed down more. So in this instance, the pressure of the gas is going to be less than pressure of the atmosphere. And again, we call that P of the room. And now all I have to do is just take this difference, and the difference between 130 and 26, I'll just do 130 millimeters minus 26 millimeters, and that equals 104 millimeters of mercury. And again, I'm trying to I always take the difference in the height, but I got to figure out what to do with this height. In this instance, since the pressure of my gas is going to be less than the pressure of the atmosphere, I need to subtract that height. So P of the gas is less than P of the atmosphere. I'm going to do P of the room minus P of the difference is going to be equal to P of the gas. All right. Remember, the only reason why I'm doing a subtraction is because the pressure of the gas should be lower, and it's lower than atmospheric pressure. So again, my pressure in the room, which is given to me, was 730. So I'll do 730 millimeters minus 106 millimeters. And 104. That was a math error. 730 millimeters minus 104 millimeters, and I get 626 millimeters of mercury. Okay, oops, you can't even see that. All right, so again, to quickly recap before I end this video with manometers, the manometer is open on one end, and I have a pressure of a gas that's pushed or being pushed by the atmosphere. In this event, the pressure of the gas was pushing more on the atmosphere, and you could see that because this height is lower than this height. It was pushing against it to make it go against the atmospheric pressure. And so I had to add the difference to the atmospheric pressure, or the pressure of the room. For this bottom one, I could see that the atmospheric pressure, which is being pushed down, so this is P of the air, that's pushing down, is greater than what the gas is pushing back. So, and I could see that because this height is lower than this one. It pushed more against it. That means I had air particles that were pushing down. Okay, and so because of this, my atmospheric pressure was greater than my pressure of my gas. So I will say that the pressure of the gas is less than the pressure of the atmosphere, and I have to subtract that difference to make it less than the atmosphere. Okay, hopefully this video is helpful. Please watch this video when you are studying for your test, and you need to watch it over this weekend. This is going to be great review to help you with some of your questions that you will see on your unit test, and you will see questions like this on your final. Alrighty, if you have any questions or concerns, let me know and comment on the video.